we hate code. This is not from me, this is from one of our customers. They really said that to us, which was quite interesting. But let's dig into that. So my name is Gerrit Grunwald, I'm working for Azure. We do JVMs, as you already heard. But yeah, that should be it about me. Who loves to maintain bad code? Yeah, some people do. Some people don't. And bad code is a little bit, it's hard to define. So I have two different things like legacy code, right? And then we have dead code. And there's one other thing, I will come to that a little bit later. So if we talk about legacy code, then that's code that was written for no longer supported operating systems, hardware, and so on, APIs. It cannot be tested automatically. It's no longer developed or maintained at all. Lacks documentation. In short, it's code you're afraid to touch, usually, right? So how to deal with it? It's not really a big secret. You can refactor it, rewrite it, find out if it is used at all and remove it. So did someone do that already? I mean, remove code just because it was not used anymore? Very good. And did someone also did a complete rewrite of something? Was it fun? But afterwards it's cool, isn't it? So once you did it, it's great. So that leads me to dead code. And again, that's not really a good specific, or let's say, description of what it is. So it's unused imports, variables, methods, classes, stuff like that. Code that is unreachable, redundant, obsolete, commented out. Who does that? Comment out code. I do. I do it a lot because I can't really get rid of it. So if I write some code that I really like, I keep it. And then I can't delete it. It's so good. Maybe I need it in the future. So I just comment it out. And I wrote some libraries that have this stuff still in there. I can't get rid of it. So it's really hard for me to do that. So yeah, so the risk of keeping this dead code and legacy code is probably, it increases complexity, obviously, right? So if you have young developers entering the company, and I was in that situation where someone entered the company and another guy said, so maybe you should take a look at the code first and then we talk about that in a week. And the young guy was really like, okay, I do it. So he was totally into it. And a week later he came back and said, yes, I think I got it. I got all this code. And then the other one said, this one, we don't use that code anymore. So sorry. He was like, okay. So stuff like this happens. So it can reduce performance. You can introduce bugs, right, by this stuff, which leads to security and vulnerabilities. And also, it can really delay code reviews, right? Because if you have stuff that is not really needed, but you have to review it, just sucks, right? Well, but removing that code is also not really that hard. So who's using IntelliJ in the room? Visual Studio Code. What else do we have? Eclipse. NetBeans. Nobody? Okay. Well, so the majority uses IntelliJ. And IntelliJ, it's super simple. As you can see, if you're in the code, the grayed out stuff is a method that is not really called in your actual code, at least in the stuff that IntelliJ can see, right? So, and then you can find these things and remove it, which is pretty simple in IntelliJ IDEA. And the same goes for SonarQube IDE. Does someone use that one? Which has very much the same. It's a little bit more configurable. You can configure other stuff and then you can run it. You get pretty much the same results. You can remove the code if you like, right? So this is cool, all easy. Who knows OpenRewrite? Someone using that? Which is pretty interesting because this is a community-driven open source project from Modern, and they enable developers to effectively eliminate technical debt. So what they have a auto-refactoring engine, and they use so-called recipes. So what they do is, so you have a recipe, for example, to remove unused private methods, right? And then you add that to your, so let's see, we have this same code, and method 3 is not used. So what you can do is, in your Maven for Gradle's the same. So you add the plugin, which in this case, or the recipe, which is the removed unused private methods here. And after that, you can just do mvn rewrite run. And before it, your code looks like this, and it will just remove the stuff from the code directly. From the complete code base, if you like. Depends on what is in the Maven in your Maven file and what is the coverage. It can remove all this stuff for you. It's a bit scary, to be honest, because you just have to trust that it works, right? Because you will have to still do the pull request and review it. But when I did it the first time, it's really like, it doesn't really feel good if something is just removing stuff from your code base. Everything is still working, but it takes some time to get used to it. But it's pretty cool if you have to remove code, let's say, in a bigger way. Because everything else which is in the IDE always means you have to really open the project, check everything. But if you have multi-staged Maven files and all these things, then it might make sense to use something like this. Here you can find more information about it. Right, this is all cool, right? So this is dead code, and we know there are tools how to remove it, and also with the legacy code, this is not really new to us. So what about this stuff? Who knows what zombie code is? Which is another one where it's not really a sharp definition of it, but that's quite interesting, because this is code that is maintained by you, but actually is never really executed in production. The worst case is the only stuff that executes your code is your test. And that happens, right? A simple example is a REST endpoint, right? Who knows the situation that a product manager comes to you and says, oh, we have this customer, we need this specific endpoint, it's very useful, and then, okay, there's a decision, you made it, you added the endpoint, but did you track if it's really used in production? Some people do, some companies do that, but usually this is not really tracked. That means you have lots of endpoints, and everything that is behind the endpoint, you never know if this stuff is really called in production. And that's, when I heard that the first time, I was like, hey, yeah, come on, couldn't be really that much, but I was surprised when I got some numbers. So yeah, it's also code that is in frameworks that is not used. Who's using Spring Boot? Yeah, and Spring Boot is fat, right? We know that. And it comes with all these things. And you can't really get rid of this stuff. This is something, for example, you can't change, right? Because you can't just remove code from Spring Boot. But this is also called zombie code, because you deploy it, it's there, you don't use it, right? The same goes for third-party libraries, where you have unused dependencies, for example. One example would be, we had a customer who came to us and said, we have a problem, we have microservices, and we would like to keep them as small as possible, but we have thousands of dependencies, and we think that most of them just use one or two methods in that dependency. So this is stuff where you drag in a whole library and you don't really use the whole code because we are lazy, right? I have an example for that. Yeah, it's the worst case. Code is only called by your test. So that means you run it, IntelliJ won't find it, SonarQube IDE won't find it, because it's called, it's all good. But the only thing that calls it is your test. So you prove, okay, we tested it, we maintain it, we take care that with every new JDK and every new version, everything's fine. But in production, nobody really uses that, right? Which really sucks. And this is also one of the reasons why this happens. So is someone working in a bank or insurance company here? Because this is usually, it doesn't really apply to all companies, but if you have old code bases, and usually banks and insurance companies have, then they have projects, internal projects, that cover specific parts of their business, and over time that changes, and they have new projects coming in covering parts of the old project. So they take over, right? And then nobody really knows, is the old stuff still in use, or is it only the new one? So we keep it. Because we don't know. That's the approach, usually. So yeah, this is a typical story, right? So this is something you might be faced of. Okay, we have to multiply matrices, right? This is the formula. It looks very strange to some people. So how to do it, right? So usually what happens is the guy who has to do it says, shit, I have to do this matrix multiplication. Does someone know how to do that in Java? And then someone in the office said, oh, yeah, there's Apache Commons. You can do that. Okay, cool. Add it as dependency. Bam. This is what you add. This is what you use. It doesn't really make sense, but this is how we work, because we don't have the time to write every code new. So we just use the stuff that is already available. And because it's useful, we have libraries that cover all kinds of things, like math libraries that cover all kinds of math, but we just need one method. Okay, no problem, we add it. Maybe we use the other stuff in the future. Sometimes it's easier just to copy the code out of the library, because if it's open source and the license allows it, then it makes sense to do that. In this case, it would be 2 methods, right? So stuff like that. It's really, and so you add code to your code base over time, right? So the question is how to find that stuff. Well, the only thing where you can find it is in production, in a running system, let's say. Could also be a staging one, but that doesn't really make sense, right? So that means you can use something like tombstone logging. Does someone know what that means? It's pretty simple, sounds stupid, but works. So what you do is, just an example with log4j, you use static initializers of classes, and then you create custom log levels, for example. Right? So this would be an example how to create a custom log level for used class or used method. It's just the upper part, the other stuff is just the pandas. And what you do in the code is then you have the class, you have the static initializer. That means the static block will be called every time you initialize the class, and then so you can log out something like used class. Use the log level used class. In this case, you can add a string if you like. If this is the code, and you see we only call method 1, 2, and 4, so 3 is never called, then in the methods, we use the log level used method, right? And then we add some text in the end. So this is pretty simple, but you already get the idea. You have to add that to all methods and all classes. There are tools to do that, and it comes with an overhead, probably, because it's a lot of logging, but you can at least find all the stuff that is called in production, right? So this would be the output, but there's still a problem because we now have the stuff that is used, how to find the stuff that is not used. And that's not so easy because it's not called, right? So how should we figure that out? So that's not so hard because there are tools like ASM tools. Does someone know these tools? They are also used in the JDK, will be replaced by the class file API from JDK 23. And with this stuff, you can, for example, run these tools against a jar file, and it gives you all the classes and all the methods in that jar file by name. So what you do is you create this output, and then you create a diff from the logging and all the classes and methods, and then you get the list of stuff that wasn't called in production. And this is how it works. So then you have to remove it manually. Again, this is not really fun, right? Because if you just have a list of classes and methods and you have to go through your code base, find the class and the method and remove it manually, it takes really long time. But it is possible, right? So, but a lot of work, yeah, as I said. Let's take a look at other solutions because we are not the first ones who thought about that. So you can use something like JaCoCo. Who knows JaCoCo? Okay. Scavenger, probably nobody ever heard about that. And OpenRewrite and Intelligence Cloud. These are the combinations that you can use to find that zombie code in production. So they all use Java agents. Who knows what a Java agent is? This is not related to AI at all, right? Okay, because some people, in one of my calls, someone said, yeah, but which model do you use? I said, what? No model. This is not really AI. So if this is the JVM, it has different parts like class loader subsystem, memory system, and also the execution engine. And when you start the JDK, whatever it is, the JVM, it comes with an API. It's the instrumentation API, so you can talk to the running JVM. And for this, you need an agent, which again is a Java program. And you can write it, and then the agent can talk to the running JVM, and it can create hookups to specific parts. For example, a callback to the class loading subsystem. So every time a class is loaded, the JVM will trigger the agent and tell the agent what class was loaded. Unfortunately, this comes with a little overhead, and most of the agents in the field are really not built for this because they collect all kinds of stuff. So, but then you get the information at least. If we take a look at JaCoCo, then it's a tool to report code coverage. So it's not really made for production use. It's made for development. You can use it to detect dead code and zombie code. Let's take a look at that, how to do it. So we have a jar file, right? So we deploy it in the JVM. We attach the agent to the JVM. This is the JaCoCo agent. And because this is not made for this, you really have to strip down the packages the agent should look at, not at all the packages, right? Because then it really slows down the system. But then this one is reporting all these classes and methods to the JaCoCo engine. And then you run it for some time. And that's the whole problem with this whole thing. Because run it for some time can mean run it for a year. And this is no joke. Because if you have insurance companies and banks and other companies, you have jobs that just run once a year. And you have to make sure that these jobs are really triggered in that time frame. Otherwise, it will be reported as dead code. You see, it's not really that simple. So usually this is the staging process. You do it once for 3 months, you check the first time, another 3 months, and so on. So then you use the JaCoCo CLI to gather the data and create a binary file, and then from that you have again call the JaCoCo CLI and pass all the class files, because they also need to know what is in the code completely. And then you can create a report, and then finally in the end you have to remove the code manually again. This is how it works. So this is one of the JaCoCo reports. People who know JaCoCo know the reports. So you can find zombie code by using JaCoCo in production. It comes with a little bit overhead, and it's a little bit more, let's say, fiddly to do that. If you're interested in that, there is a company in the Netherlands called Picnic, and they use it in production, even in a Kubernetes cluster. So you will find information here. I'm not sure if the slides will be collected afterwards. If not, just ping me on LinkedIn, and then I can send you the PDF, because this is different every time, because now we just have 35 minutes. I have to strip it down. I can send you the full deck if you like. All right, so, okay, picture taken. Okay, cool. Then we take a look at Scavenger. Did someone ever heard about that? Probably not, because this only lives on GitHub. And it's a little bit strange project. It was created by one person years back under a different name. He never really had success with it, so he just let it sleep away. And then some Korean guys took over and created Scavenger out of it. So it's in the hand of, I think, 8 to 9 Korean developers. And it's made to find zombie code, right? So it's a free tool, and you don't need to change any code. It stores the data in MySQL or Vitess or H2. And it provides a web interface to get the data out of it. And it exports it to a text file in the end. This is okay to monitor a couple of JVMs. It can not just only one, but you can do it with a couple at the same time. So if you would like to find zombie code here, you deploy your jar files to the JVMs, attach the agents. Then these agents talk to a so-called collector. This is how they name it. And the collector just collects all the data from these agents and then saves it into the database. Pretty simple. This is the whole thing. And then again, you run it for some time. This is the same for all these things. And then you have the web interface where you can just check, create a snapshot from the actual data, and then create a report. And in the report, you get something like this. It's a nice tree map, and you get some information about the methods that have been called and have not been called, how often some methods have been called, which is quite interesting. But it also means that they trigger the agent every time they call a method. That means there is a performance impact here, definitely, because it's really a lot. With every method call, the JVM has at the same time trigger the agent, right? So that means this comes with an overhead. But you get this file and you get a text file out of it, that's it. And it's, how do they name it? I think it's not a CSV because it's not comma separated. I think they name it TSV, it's tab separated values, right? So this is the file that you get out of it. Okay, this is the file. You see you get the timestamp, the package with the class name, and then method names. And I think even if it's used or not used, it's just a binary 1 or 2. And then you have to, again, go through it, get all the stuff that was not used and remove it manually, right? So this is, oh yeah, here you see. You get used, unused code. You can do these snapshots every time. You can analyze it in the web interface, and you get method level resolution, right? Here's the GitHub repository if you're interested in that. It's got better over time, because in the beginning they didn't have the collector in between, and now they added that. So it is easier to set up. In the past, I didn't get it running, and I got Korean error messages, which really sucks. But this is now better, so it works. But it comes with a little bit of an impact. The problem is still you have to manually remove code. And I will come to a point why this really is important. So there is a solution around that manual removal, which is annotations, where with JDK5 we got deprecated, and with JDK9 we got deprecated with some additional information. Right? There is something like since, where you can, it's just a string, should be a timestamp, could be whatever, and there is something like for removal equals false or true, right? So it means you can annotate code and say this should be removed or not. Without changing code, it's still in your code base. You can just commit, and then the IDE suddenly will show you all the classes like a strike through, and also the methods. If they have this annotation, this is only for classes. But you can also add something like for removal equals true or false. And if you use that, then you could do something like, in the first step, after 6 months, you mark everything that wasn't called with removal equals false, right? Then you repeat this step a couple of times, right? Like how often you need it. And then in the end, you are pretty sure you've covered all the stuff that was called or not called. And if it was called in between, you have to remove the deprecation annotation again, right? So and then in the final step, you can set all the stuff that should be removed to removal equals true. And with the right tool, like OpenRewrite, you can then remove this stuff automatically from your code base. If it has this deprecation, the last one, for removal equals true, right? And this is what we did with Intelligence Cloud and OpenRewrite. It's pretty much the same as we saw before, right? So now it's just stored we store everything in the cloud instead of a local database, which makes it more scalable. And we do the same. We offer information about used and unused code, but we only trigger a method once it was called, right? Because then in the time you create the snapshot or you create the report, you can check if it was called or not to avoid overheads, right? So the overhead from the agent that we use is below 0.1%. So it's really low, so you can really use it for production stuff. And it's made to monitor thousands of JVMs at the same time. So you can deploy your stuff again in the JVMs. You attach the agents, which can be done automatically, so you don't have to do that manually, right? So there are tricks how you can add an environment variable to the operating system. Once this is set, every time you start a JVM, it will call the agent automatically, so you don't have to do that. We have a forwarder, which is not the collector, but it's exactly the same thing, but we had it before Scavenger. I guess they just saw it and just copied the idea. And we have something called an app tag. So because the problem is, who's deploying multiple times a day? Someone? Or a week? Yeah? So that means you have lots of versions, right? So how to find the version that has the new code and not, and stuff like this. It's not so easy, right? If you have to run it for 6 months, means it's lots of versions in there. And now you have to find the code that was called or not called in all these versions. So for this reason, we have this tagging where you can tag an application, a deployment, right? Like it's the Java program with the version number and the build number. And then afterwards you can filter for that. So you can find it in the end in your data again, which with the other stuff is not possible. And then this is, again, talking to an API, and then this stores it into the cloud service. So, again, you run it for some time. Once it's done, you can also get a web interface, see a report, looks like this, not really useful, but at least you get an idea. Much more interesting is I wrote an IntelliJ plugin for that, because I thought if I'm the developer of the code, it would be great to have the data directly in the IDE, right? Because this is where the code lives. So I would like to see the stuff in there. So, and then because the IDE has access to the code, I can mark stuff in the IDE directly as deprecated or not deprecated, automatically based on that, right? So that means I load the report for this project, And then I can do something like mark all the stuff that was not used as deprecated equals true or false, whatever. I can even remove code in the IDE. And I can jump to methods. On the right side, this tree, this is the stuff that comes from the report. And the left side, you know, this is the normal project tree. I can click on all of these, and then it will directly open the method or the code or the class in the IDE, in the editor, so I can check what it is. And if I like, I can directly also automatically add to all the project stuff, the annotations, and remove even code if I like. So yeah, I already said that. You get also additional information about a package, what was called in the package or not, stuff like that. So it's quite interesting. Problem is, this is just for single projects. Right? It doesn't really work for lots of projects. And I always said that the problem is the manual removal. Why I say that is we have customers, and this is no joke. One customer, and you probably heard of Netflix, right? It's a customer of us. They run 1 million JVMs. And this is not a joke, right? So if you have to monitor 1 million JVMs and find dead code in this 1 million JVMs, this is just a hassle. Another customer has, it was around 3,000 applications running at the same time in hundreds of JVMs, and they would like to filter all this stuff and find the dead code. So you get the idea that something like an IntelliJ plugin doesn't really work here, right? Because it's just too many code projects are involved here. So if you have many projects, then the next step is use Modern with OpenRewrite, because they also have a cloud service. And they directly talk to the intelligence cloud service, get the information, analyze it, and then they do the stuff that I do in my plugin automatically. They can mark all the things with annotations, and you do that for the first time with removal equals false, and then you repeat that step as often as you need it, and then in the end you can decide now is the time to really remove code, and then they can automatically remove the code in all of these code bases for you. Of course they need access, right? So this is the other thing, but this is possible. Technically, we have customers, they use it, and they are quite happy with it. But it's not for everyone. This is really for huge customers. And usually in Europe, we don't have this super big cloud companies that we have in the US. So that might not really work for companies in Europe as it works for companies in the US. But this is what we do with this stuff. If you need more information, you can get it here. It's not for free, sorry, because we also have to pay AWS for this stuff. We host it there. But yeah, at least this is a solution to solve that problem. Of course, we have some difficulties avoiding zombie code. I just say, yeah, we have all this code. You should get rid of it. It's not always possible. As I mentioned, if you're a library developer or framework developer, you really have to be careful before you make methods public, because you probably can never get rid of them again, because you as a maintainer have no idea what is used or not used, and there's no way of figuring that out. So this is one of the problems. AI-generated code, totally different story, because you might not even know what the AI agent generated as code and made public, right? So this is something probably not for seniors, but junior developers, it's really tricky if they play around with AI, generate code, and then you have to check if it's really worth it or not, right? It's a different story. If you have frameworks like Spring Boot, there's no way to get rid of that stuff, right? Which also leads to monitoring. If you monitor all that, you have to make sure that you mainly monitor your packages where you have control, and not monitor stuff that you can't change anyway, right? So, okay, conclusion. Zombie code is real, but it's really hard to find. Monitoring takes super long, and this is the biggest problem, to convince management that it makes sense, right? Because it really saves a lot of money. And this could be in the millions. Sounds strange, but it is. So JaCoCo, Scavenger, or Intelligence Cloud can help. So if you would like to play around with it, Scavenger is the best thing to play around with it. This is free, and it's easy, more or less easy to set up, and you can try it on your pet projects and see if you can work with it. Removing often needs domain knowledge, so you can't just remove the stuff, not always, because you really need people that know, especially in banks, insurance companies, why do we have this code? Why does it make sense to keep it, right? And developers not always know that. So with this, I would say go zombie hunting and just check it out if you're interested in that. If you have questions, you can come to me after this or just ping me on LinkedIn if you not really would like to talk about it in public. Thanks for attending, and I should ping you to this one. Vote for this session. This QR code should bring you to the JavaConf. And that's it.